All right. So I think I wrote down like what the requests were. So I think the first one is going to be that last inequality. So 16, one of these guys. So this one, I think someone asked about 17 yesterday. This is more like what you would see. Like 17 was really hard. But this is more like what you guys will see tomorrow. I've got one just like this. So there were 3 steps. First step said you take each of the denominators and set them equal to 0. So whatever, because remember we're going to end up making that number line. And so these ones, we start with the 2x, and then if you divide both sides by 2, we still just get 0. So we get x equals 0, that's a repeat of x equals 0, and then obviously 4 does not equal 0, so that doesn't give us another one. So we've got that first one, just x equals 0 from step 1. And then step 2, the note said solve the related equation. That just means replace the inequality with an equal sign. So we'd have 3 over 2x minus 2 over x and then equals 1/4. So these ones, the monomials, people get super confused with like what pieces you're supposed to have. So the LCD, we're supposed to be getting all those denominators to cancel. And this, like the 2x, you guys know how if you had like an x plus 2, that's one factor, and you can't actually just take a part of this. So 2x isn't actually one factor, it's 2 factors. Like it's 2 times x, and those are separate, and you could cancel them if you're able to. So this one needs a 2 and an x, and then this one needs an x, which we're good, and this one needs a 4. Like since we already have a 2, we just need to multiply in another 2, and that way we have the 4. A lot of people have been using 8x, and like that, the 8x would work, it would just be a little bit bigger than it needs to be. So this 4x is all that we need to get everything to cancel. So then this is where you go through and multiply everything by 4x, so distribute that LCD to all these terms, and then the denominators should all cancel out. So these ones, like this guy, you've got 4x over 2x. So the 4 over 2 would reduce down, and it would leave a 2 behind. And then in this next one, the x's would cancel, and that 4 would still be left behind. And the third one, the 4's would cancel, and the x would be left behind. So this, like this first one, we have 3 times 2 still, which is 6, and then minus 2 times 4 is left in the next one, so that's 8. And then on the right-hand side, all you have is a 1 and an x, so you've just got x. And then subtract that, we end up with x equals negative 2. So this, I don't know if you guys remember 17 yesterday, we had 2 numbers from step 1 and 2 numbers from step 2, so that made a really complicated number line. This one, we've just got 1 number from step 1, 1 number from step 2. So step 3, you line up this whole number line, so you've got negative 2 and 0. And remember, make sure those are in numerical order. All right, so then we pick different test values that you can plug in. So say we plug in negative 3 over here. So this, the inequality, we've got 3 over, and then 2 times negative 3 would be negative 6 minus 2 over negative 3 is greater than 1/4. So these, like on the test tomorrow, I would just plug the left-hand side into the calculator and then see if it does come out greater than 1/4. So this turns out that it doesn't. So like this ends up being false. And then if you plug something in between here, I would say plug negative 1 in. If you plug negative 1, then you end up with a true statement. And then if you plug in something bigger than 0, you end up with a false statement. Remember, like I was telling you guys yesterday, though, make sure you're actually showing me the test values for every section. And then your final answer is you take whatever the true region is and you write it down as an inequality. So this one, when you're in between 2 values like this, you write it as a 3-piece. So you would say that x has to be greater than negative 2, and it also has to be less than 0. And that's where the 3-piece inequality comes in. Okay. You guys good on that one? Okay. So then the next requested, there were a few on the fronts that had the same number, and these ones are all just like the factoring and canceling. So 2 and 3 and 5 all had the same number of votes. So I'll go back to 2. This one, people never like the ones in the numerator when they have something in front of the quadratics. Like the 2k squared means that we'd have to guess and check when we're factoring. So this, we start with 2k times k. And then the blank spots here, they're supposed to be multiplying to negative 15. So probably, 5 and 3, but you have to pick where the 5 is going to go, where the 3 is going to go, which one is going to be negative. And it ends up that the 3 goes here and the 5 goes here. So then my outside term is the 2k times 3, so that's 6k, and the inside is 5k. So in order to get the negative 1, the 6k has to be the negative 1. So we put the negative sign there, and then the 5k has to be the positive 1. So like the guessing and checking literally means just guess where the 15 might come from and then check to make sure that you get your middle term. And then this, the k squared minus 9, that's the difference of squares pattern. So that is k plus 3, k minus 3. So that the positive 3 and the negative 3 multiply to the negative 9, but then my outside and inside terms would cancel. So these, like once they're all factored down, then the numerator has 2 separate factors, the denominator has 2 separate factors, and since these are identical, then they can just cancel each other out. So then you just have 2k plus 5 over k plus 3. Good. Questions there? No? Okay. And then 3 was another one. This like just a little bit expanded. You were doing factoring and then some extra multiplying before canceling. All right, so this one, the numerator here can factor down. So this, the x squared, we just start with x times x, kind of your normal factoring. And then these numbers are supposed to be multiplying to a negative 24 and adding up to a negative 5x. That would be a negative 8 and a positive 3. And then the denominator, it doesn't factor in the traditional sense, like the 2 sets of parentheses, but it does have a GCF. That's something people forget about a lot, so make sure you're looking there. So between 6x and 2x squared, we have a 2x that we could factor out. So this would leave behind just a 3, and then this would leave behind just an x. So that, like the one on the left factors down quite a bit. The one on the right, you actually can't do anything with that. So you've got 5x squared and then 8 minus x. So these ones, like at first glance, a lot of people don't really think that they see anything that can cancel, but like the x plus 3, 3 plus x, that's technically the exact same factor. So they're both positive, so these would cancel out. And then this, like the 5x squared, remember 5x squared isn't one factor, it's actually technically 3, like it's 5 times x times x. So you can take one of the x's, like this x squared would leave an x behind and this x would cancel. It's like the x squared over x right here can reduce down. And then the one that people miss a lot is the 8 minus x, the x minus 8 and the 8 minus x. These are almost the same, but they're opposite. It's like the x is positive here, negative here, and the 8 is negative here and positive here. So if you cancel something that's opposite, it leaves a negative 1 behind. That would be like if you had a positive 8 over a negative 8, those would reduce down to a negative 1. So then to clean that all up, the only things left, we have a negative 1, a 5, and an x in the numerator. So that would be a negative 5x. And then in the denominator, the only thing that got left behind was this 2. So that would be our final answer. Then number 5 was the next one. This one was an addition and subtraction, which I think we did one of these yesterday. So this one, addition and subtraction, you have to find the LCD, and the goal of the LCD is to get the same denominator so that you can add them together. So these ones, I would break them apart into their smallest pieces. So this, like the 12 is 3 times 4, and then you can break the 4 down to 2 times 2, and then you've got all of the x's and all of the y's. So the LCD 12 is 3 times 2 times 2. So that's completely broken down. The x to the 4th means we've got 4 copies of x and then 1 copy of y. So like this, all of these pieces from this first denominator have to be included in our LCD. So this is just the 12 x to the 4th y completely broken down into all its individual factors. And then the 5x squared y cubed, I have to have all these pieces as well. So this is where if you're missing anything from the LCD, you add it in. So like it needs to have a 5. It doesn't yet, so I put a 5 in right here. It needs to have 2 copies of x, which you're good because we have 4. So like these 2 copies get included. And then we need a y to the 3rd. So since we only have 1 y, we need to add in 2 more copies of y. So all those things would combine up. And these, we'd have 3 times 2 is 6, times 2 again is 12, times 5 is 60. And then we have an x to the 4th and a y to the 3rd. So like that's the eventual goal, is to make sure that both of those terms have the same denominator. Like both of these have to have this as a denominator. So the next step is multiplying top and bottom by whatever each term is missing. So if you look at the first one, right now it's a 12. If it needs to be a 60, then I have to multiply by 5 over 5. It's like 12 times 5 gives us 60. So I'm going to multiply 5 in the numerator, 5 in the denominator. It needs an x to the 4th, which it's already got. It's like the x's are fine. The LCD says it has to have a y cubed, but since it only has a y, you would multiply in y squared, top and bottom, so that you have all the copies that you need. And then you do something really similar with the other one. So here, like, it's a 5, but it needs to be a 60. So you'd multiply by 12 over 12. And that way, the 5 times 12 gives you the 60 that you're supposed to have. I only have 2 copies of x. I'm supposed to have 4. So I'm going to multiply top and bottom by 2 more copies of x so that I can match the LCD. And then I'm supposed to have 3 copies of y, and I already do. So you don't have to multiply any extra y's. So this one, the numerator is 25y squared over, we end up with 60x to the 4th y cubed, which is exactly what we were supposed to have for the denominator. And then minus, next piece, I have 1 times 12x squared, which is 12x squared. And then when you multiply all these pieces out, you get the LCD that you're supposed to have. It's like this is the point that you're supposed to be at, where the 2 denominators match. And then if they match, you can add the numerators together. And they don't have like terms, so you would literally just write 25y squared minus 12x squared, and then put that all over the common denominator. People get mixed up here, like trying to cancel things and they can't cancel. So remember, like none of these can cancel, none of these can cancel. Like you can't just take little bits and pieces because the numerator is 1 factor. So you can't cancel little parts. This is actually as far as that would go. Okay, questions there? No. All right, next request was number 10, one of our graphs. So this one is an 8-4 graph, and what I told you guys was either I ask for domain and range or I don't. So like 8 and 9, I asked for domain and range, so that's an 8-3 graph. And then for 10 and 11, I didn't. So that is actually an 8-4 graph. So 8-4 graphs, we did x-intercepts, y-intercepts, horizontal asymptote, vertical asymptote. So for the x-intercept, you take whatever expression is in the numerator and you set that equal to 0. So that, if I just divide both sides by 3, then I just get 0. So I get x equals 0 as my x-intercept, so I'm going to start putting things together over here. So along my x-axis, the point that it crosses through is at 0. So that's just right at the origin. And then for my y-intercepts, for the y-intercept, you do y equals, and then you plug in 0 for x. So rather than setting it equal to 0, you plug in 0. So we have 3 times 0, and then over 0 plus 3 squared. So the numerator ends up being a 0, and then the denominator is 9. Like 0 plus 3 squared is 9, but 0 divided by 9 is still 0. So that's my y-intercepts. A lot of times you'll have a different x-intercept and y-intercept, but here they both happen to be at the origin. So we just have one point right here. That's the x-intercept and y-intercepts. And then horizontal asymptote. You guys had 3 different rules, and it depends on which degree is bigger, the numerator or the denominator. So the numerator technically has a degree of 1, and then because of this squared, the denominator has a degree of 2. So if the numerator has a smaller degree than the denominator, then the HA is just automatically y equals 0. So that's, again, only if the numerator has a smaller degree than the denominator. So this, got this dotted line right at y equals 0. And then last piece is the vertical asymptote. So you take whatever is in the denominator and you set that equal to 0. So the x-intercept is setting the numerator to 0. The vertical asymptote is setting the denominator equal to 0. So for this one, we would take the square root of both sides. So square root of 0 is still 0. So I have x plus 3 equals 0. And then subtract the 3 from both sides. So I end up with negative 3. So go 1, 2, 3. Okay, and then this is, so I'm gonna show you what the graph looks like, because this is the point where you guys use Desmos on the quiz. So we would just graph, so you'd have 3x over x plus 3 squared. You can see it looks something like that. So you've got two little pieces, goes through the origin. So like this piece, there's this little shape right here. And then this piece is kind of weird. It goes along the dotted line, it goes through this point, and then immediately like comes right back down and just glides along that dotted line. So it looks something like that. All right, and then number 12 was the next request. So this is one of the variation ones. This one's a little bit more straightforward than number 13. Because there's only two variables. So 12 says y varies directly as x. So when they say that something varies, that one's automatically in the numerator. So that's where the y goes. And then it says directly as x. So I talked about that alliteration clue. So like directly means divide. So we would divide by the x. So your setup would be y divided by x. So they tell us y is 7 when x is 1.5. So we have 7 over 1.5. And then it says find y when x is 4. So you do y over 4. So you set it up like that. And with fractions like that, I would say cross multiplying would be the best way to go. So if you cross multiply the 7 times 4, you get 28 equals, and then cross multiply here, you get 1.5 y. So then divide both sides by 1.5. These would cancel. You end up with 18.6 repeating, so it ends up like 18 2/3. So you can either do like 18.6 repeating or 18 2/3, whichever way you prefer, or just like 0.67. Okay, so that one's pretty straightforward. Questions on that one? Okay, and then back to number 11, another one of those graphs. Okay, so this one, since I didn't ask for domain and range, this is an 8-4 graph. So for that one, you do x-intercept, y-intercept, horizontal asymptote, vertical asymptote. So the x-intercepts, you take whatever expression is in the numerator, so that's the x minus 3, and set that expression equal to 0. So for my x-intercept, I would add 3 to the other side, so I get x equals 3. I'm going to start plotting that. So go 1, 2, 3 on your x-axis. And that's where it's going to cross through. And then y-intercepts, for the y-intercept, you do y equals, and then you plug in 0 for x instead of y. So you do 0 minus 3 over 0 minus 2. So the numerator ends up being negative 3. The denominator ends up being negative 2. So negative 3 divided by negative 2 is positive 1.5. So y-axis, you go 1, 2, and then 1.5. You just approximate right in the middle there. And then horizontal asymptote, these are the ones where you compare the numerator's degree and the denominator's degree. So x to the first is just x, so a degree of 1. The denominator also has a degree of 1. So this, you look at the ratio. That was a different rule. So if the degrees are the same, you look at the ratio of those front terms. So this is just a 1x over 1x. So 1 over 1 would be 1. So it's not the degrees that you look at the ratio of, it's the numbers in front that you look at the ratio of. And then for vertical asymptote, you take whatever expression is in the denominator and you set that equal to 0. So the x minus 2 is from the denominator. If you just add 2 to both sides, we get x equals 2. So the horizontal asymptote is right here at y equals 1, and then the vertical asymptote is right here at x equals 2. So then these ones, the way to finish off 8-4 was you guys used, well, we used Desmos, but if you have a graphing calculator, you could do that too. So we graph it, and then it looks like this. So you just connect the dots and use those asymptotes to kind of guide where your graph should be. So it goes up through this dotted line, hits this point, and then goes along this one. And then same thing here, it goes down this dotted line, curves through, and then goes right here. So that's what the graph ends up looking like for number 11. We also, let's see, same number of votes was number 14. If you guys flip and look at that one. So 14 was our other equation. We did 15. In 15, it's sort of the same thing as 17. 15 is probably more complicated than you'll see. But 14 is a pretty good indicator of what you could see tomorrow. So 14... Okay, so these ones, with these equations, you're trying to find the LCD, and then you want to use the LCD to cancel the denominators. So first thing you need to do is make sure that the denominators are factored, if they can be. So like this one, the k minus 3 doesn't factor, so you just leave that. And then the k plus 4 also doesn't factor. Oops, sorry, that's k minus 4. Just copied that down wrong. Yeah, okay, that's right. And then 25, this is a k squared. There's no GCF, so you just go right into k times k for your factoring. And then the numbers, these two numbers are supposed to multiply to a positive 12, and then the middle term is supposed to be a negative 7. So they're both negative. And then multiplying to 12 and adding up to 7 would be 3 and 4. So you can see, like, this is not a coincidence. It usually happens. You can see that these two on the right are the same as the two that you've got on the lefts. So the LCD that we use to get everything to cancel. So we grab this one, the k minus 3, go to the next denominator and write that down too. So that would be a k minus 4. And then you can see these two are already up here in my LCD. So I don't need another copy of those. So these ones, the equations, you're taking the LCD and using it to get everything to cancel out. Okay, so you take this LCD, the k minus 3, k minus 4, and you multiply everything on both sides. So both of these expressions get multiplied by the LCD. And then when you do that and you do the canceling, what should happen is that all the denominators should cancel out. Otherwise, you may have chosen the wrong LCD. So the k minus 3s here will cancel, k minus 4s here will cancel, and then the k minus 3s and the k minus 4s on the right-hand side. So like if you look, you see the denominators are gone, and that's what should have happened. It's like here, this first part, we have 3 times the factor k minus 4. So you would distribute the 3, and then we have 3k minus 12. Same thing with the 4. You have a 4 times the factor of k minus 3. So distribute the 4. We have 4k minus 12. And the right-hand side is 25. Okay, so these guys, we get 3k, 4k adds up to 7k, and then the negative 12s would be minus 24. So just kind of a multi-step equation here to solve for k. So you would add the 24 to both sides, and 25 plus 24 is 49, and then divide both sides of the equation by 7. So 49 divided by 7 is 7. And then for these, I talked to you guys on number 15 about checking your answers by plugging them back into the denominators, and you're just making sure your denominators don't come out to be 0. So if you plug the 7 in right here, 7 minus 3 is fine, 7 minus 4 is fine. So this is not extraneous. Okay, oh, we should have a few more. Okay, you guys good on that one? Questions? Okay. So we've got the graphs from 8, 3. So we'll do those. So we'll do 9 and then 8 and then just finish off with number 1. So number 9. And these ones, I think 8 and 9 are a little bit more straightforward. These are the ones where we did the 2 asymptotes and then did the transformation of points. So these ones, your indicators that I asked you for domain and range. That's how you know it's one of these ones. So the horizontal asymptote is always a y equals line. And in these forms, like the 8-3 form, it's always just the number on the end right here. So whatever number is by itself after the fraction. So we have y equals 4 for this one. And then the vertical asymptote is the same as what we did in 10 and 11. You take whatever expression is in the denominator and you set that equal to 0. So the denominator is an x minus 2, set that equal to 0, and we end up with x equals 2. So I'm going to plot these. So there is your horizontal asymptote, and then here's our vertical asymptote. So you've got those, and then for these ones, for problems like 8 and 9, you do your 2 original points and then see how they transform. So original points are always -1, -1, +1, +1. And then these guys, we have 3 transformations. So find the x, it's in the denominator. We have an x minus 2, and x always does the opposite. So you do x plus 2. So -1 plus 2 is 1. 1 plus 2 is 3. So those are your new x values. And then for the y values, you take whatever's in the numerator. So there's always a number up there, even if it's just 1. You take whatever that number is and multiply it by the y value, and then add or subtract this number. So -1 times 3, and then plus 4 would be 1. And then 1 times 3 plus 4 would be 7. So you plot those 2 points. So 1, 1 would be right here, and then 3, 7 would be right here. So you use those, and that kind of tells you like how close you're gonna get to this intersection point right here. So you go along here, and then it starts curving away kind of early. So there's not super tight right on this corner right here. So then come down and then start curving away as soon as you hit that point. That should look like that. And then you also do domain and range, which I think is super easy for these ones. Domain is that x can't be wherever the dotted line is. So this dotted line is at +2. So you say x can be anything except for that +2. And then the range is done the same way. You say y can't be wherever that dotted line is, and the dotted line is at 4. Okay. Good on 9? And then 8's pretty much the same, just slightly different numbers. All right, so horizontal asymptote is a y equals, and it's always just the number that's by itself on the end here. So this would be y equals -4. Vertical asymptote, you do x equals, and then, I'm sorry, it's whatever's in the denominator. So you take the x minus 3 and you set that equal to 0. So you end up with x equals 3 once you add that over to the other side. So set this up, so y equals -4. We'll go right there, and then x equals 3, go right here. And then just like we did with number 9, you take the 2 old points and transform them. So -1, -1, +1, +1. So for x, you look up to the denominator here. So x minus 3 goes do the opposite, so it means we should be adding 3 to our x values. So -1 plus 3 is 2. 1 plus 3 is 4. And then for the y values, you take whatever you started with, first you multiply it by the number in the numerator, and there's always something there, and then you add or subtract the number out here if there is one. So -1 times -1 is +1, then -4 would be -3. 1 times -1 is -1, -4 would be -5. So these ones, we have 2, -3, which would be right there, and then 4, -5. which is right there. So that one you can see the points are much closer to where the dotted lines intersect. So sketch in the graph, you go right along this dotted line, curve when you hit the point, and then along the horizontal one, same thing down this way. So this one gets much closer into the center than this one did. And then domain and range, my x values can be anything except where the dotted line is, which is at 3 for this one. And then the range, my y values can be anything except where the dotted line is, and for this one it's -4. Okay, questions on that one? Okay, so just 2 more and then we've got the whole thing done. So number 4 was a multiplication division one, and then number 1 was just reducing. So I'm just gonna copy this down first. Okay, so this is number 4. First thing here, division, you always flip and multiply by the reciprocal, so don't forget to do that. And then all of these will factor down. So 2s squared minus 7s minus 15. So this one, it's gonna be a guess and check. So you start off with 2s times s, like that. So the 2s times s would give you the 2s squared. And then the -15 is probably gonna be 3 times 5. And then our middle term is supposed to be -7s. So what it ends up being, we put the -5 right here, because then our outside term would be -10s, and then you put a +3 right here, and that would make our inside term +3s. So then we have -10, +3, that gives us the -7 in the middle. The s plus 4 squared means just that I have 2 copies of s plus 4. So just s plus 4, like that. And then this, so the next part, the division, you're gonna you're gonna multiply and then flip that second part. So multiply by the reciprocal. So the s plus 4 is now in the numerator, and there's nothing that we can do to factor that. And then the denominator would be the s squared minus 10s plus 25. And that I can factor, start with s times s. And then I'm looking to multiply to this 25, but my middle term should be a -10. So that would be -5, -5. Okay, so everything is totally factored. We took care of the division. So then you just go through anything that you have 1 copy in the numerator and 1 copy in the denominator, they can cancel. So I purposely did this one to show like which ones are canceling, because the s plus 4, when they're right next to each other, those can't cancel because they're multiplying. But this s plus 4 can cancel with one of these s plus 4s. And then there still is one left behind. Same thing with the s minus 5s. So you do like one of these can only cancel one of these. So like each of these does get left behind. So the numerator, I just have 2s plus 3. The denominator, you can FOIL it if you want. You can just leave it like this if you want. But either way, you've got both of those 2 expressions left in the denominator. Okay, questions there? Number 4? Okay, number 1, last one. This one had the least votes, so I'm assuming this one was fairly straightforward. So these ones are monomials. I'm gonna rate this out like as broken down as we possibly can, because people look at these and they think that this is one factor, and it's not. It's actually like many, many factors. So the difference is when you have addition and subtraction. So like s plus 4, that's one factor. S minus 5 is one factor. But when this is all multiplication, it's actually, I think this one has 7 different factors. So the 9 breaks down into 3 times 3. So that's already 2 factors. Each of the A's breaks down, and then same thing with the B's. So that is completely broken down. Yeah, so we end up with 7 total factors in that numerator. The denominator, the 24, you could do 4 times 6. The 4 is 2 times 2. The 6 is 2 times 3. Then I have 4 A's, 4 B's, and a C. So that one has 13 different factors. So this is where people get mixed up because I keep saying like, oh, you can't cancel little bits and pieces. There's a difference between if you tried to cancel these S's, for instance, because like this S is part of a factor, this S is part of a factor, but all of these pieces that you see up here are their own individual factors. It's like anything that you can see, you can cancel out. So like these 3's could cancel. And then you can see there's multiple copies of A. So like copy of A, top and bottom, another copy of A, top and bottom. A bunch of the B's can cancel. So B over B, another one, and another one. And then you basically just take what's left over and write that down. So the numerator, every single piece canceled except for a 3. So the numerator should just have a 3 left over. And then the denominator, I had 2 times 2 times 2, which is 8. I have 2 copies of A, so that's an A squared, 1 B left, and then the C. Never had anything to cancel with. So this is as far as that gets broken down. And if you can do it without actually writing down every single factor, that's totally fine. I think a lot of people did it that way anyway. Just wanted to show you the totally expanded version.